Today we're going to learn about the law of cosines. Now you remember the law of cosines from last year, and it looked like this. A squared equals b squared plus c squared minus 2bc cos A. Now you want to notice that this kind of looks like the Pythagorean theorem, right here, but then we've got this additional term. Now this form is helpful if you're looking for a side, because it's solved for a side squared, but sometimes we want to solve for an angle. So a variation on the law of sines, or on the law of cosines, would be if we solved for this cosine A. The way we'd do that is we'd subtract the b squared and the c squared. We get a squared minus b squared minus c squared equals this negative 2bc cos A. We'll divide both sides by negative 2bc. On this side we've got cos A, which is great. On the other side, I'm going to take this negative and distribute above, so that we've got a positive b squared plus c squared minus a squared over 2bc. Now it's helpful to know both versions. This is good when solving for a side. This is good when solving for an angle. But regardless of which one we use, we should get the same answer. Now here's every variation of the law of cosines that you might see. All three of these solved for a side. All three of these solved for the cosine of an angle. And you want to have these memorized soon. And it looks like you're memorizing 6 formulas, but as long as you know one of these, you can figure out the other 2. So as long as you know what cos A is equal to, you can figure out what cos B or cos C is equal to. So for our first problem, let's say they give us 3 sides. They tell us that A is 8, B is 19, and C is 14. Now, we have no choice. We can only solve for an angle since we're given all the sides. But the question is, which angle do we start off with? And the answer is you always look for the largest angle first. The largest angle in this case would be angle B, since B is across from 19 feet, which is the largest side. So I'm going to say that cos B equals a squared plus c squared minus b squared over 2ac. We'll substitute values in there. Okay, now we put that in our calculator, and that's going to give us some decimals. So we know that cosine B is equal to, it's about negative 0.45089. And then to solve for B, we use the inverse function. And B turns out to be about 117 degrees. So this guy up here is about 117 degrees. Now, if we need to solve for the rest of the triangle, we've got a choice. We can look for A or C, and we can use the law of cosines or the law of sines. It doesn't matter at this point. So I'm going to go back to the law of sines, and I'm going to find angle C. We know that the sine of C over 14 should be equal to the sine of 117 over 19. Then we have 19 sine C. So sine of C is equal to 14 sine 117 over 19. And that means that C must be equal to about 41 degrees. So this angle here is 41. Then to find the last angle, we can add the other 2 angle measures. It's 158. And then subtract that from 180. And we get 22 degrees. Also notice that in this problem we were given 3 sides. So this was side, side, side. Okay, next example, we've got a triangle. Let's say that we're given this side is 46, this angle is 45, and this angle is 60. We'll put these in feet. And we would like to find this distance A over here. So now we're looking for a side, so I'd rather use this form. So we'll substitute. And we get that a squared equals 1812. So we'll take the square root, and we get approximately 42.6 feet for A. And just like in the previous problem, if we wanted to solve for the other 2 angles here, we could use the law of sines for one angle, and then subtract what we found from 180 to find the third angle. And just take note here that what we were given was side, angle, side. So here are your formulas one more time. Remember that if you're given side, 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 that you're looking for the largest angle first, and that I highly suggest memorizing both forms of the law of cosines, because one is convenient for solving for sides, whereas the other is convenient for solving for angles.